All right, so homework should be out. Again, I'm not going to mark it off right this moment because I want to make sure that you are doing these correctly, because there is a couple of places where you might get snagged, and that's okay. We're here to learn, and so a few things to know that. So today we're going to be going over this. Tomorrow we're going to start our review. Thursday we'll go over the review. Then I'll give you the take-home test. Remember, the take-home test will be graded for if it's correct or not. So don't just write arbitrary numbers hoping you might get it correct. All right? Everyone feel good? Let's go. All right. So problems 1, 2, and 3. You're just trying to figure out the compound inequality from the lines that are drawn and just writing it in the right form. So I'll do a poor rendition of the mock-up that's on here. So which one appears to be the and problems up here?
1 and 2.
1 and 2, everyone agree? Yeah. And the or problem appears to be number 3. Agreed? All right, so problem 1 and 2, we can just go ahead and write it. And we want to, let's see, it says write a compound inequality is represented by each graph. So let's go ahead and just put it in interval notation. Okay, so interval notation I have from -4 to 1, both rounded brackets, and I think you're totally set right there. That's interval notation. There's nothing that he needs more. I mean, that's the best way to write it, and that's how you'll see it written time and time again. Okay, problem number 2, I'm going to use a square bracket at the 2 and a rounded bracket at 7. Why is it a square bracket at the 2? Yeah. Because it's closed, we're including it. Okay? Problem number 3, though, is an or problem. So one thing that we need to have as part of the or problems, we have to have the word or. Okay, so you have to bust out. So this is coming from -infinity, that's going to infinity. So I'm going from -infinity to 2, or square brackets going from 5 to infinity. And that's how you have to do that. So what I'm looking for on this problem is, I'm looking for that you have these two set up. I'm also looking at the fact that you have the word or in there. Is that all right so far? Okay, pretty simple, straightforward. Good?
Okay, so the or one is 2 different problems.
The or one has 2 different things there. The and you can put together. Okay? All right, so number 4, 5, and 6, and as well as 7 is they want you to create a scenario. So you might see something like this on the tests on Friday. So let's just list 4, 5, and 6. A number that is less than t and greater than 3. So I'm going to put my numbers in order. Okay? The number t we're going to use in the middle. So a number t is less than 5 and is greater than 3. Done. Okay? Yeah.
I wrote it differently.
Okay.
I said 5 is greater than t, and t plus greater than 3.
Okay.
I put t.
You didn't put it together. Okay. So let's see if we can make this work on the number line. I think you're going to be correct as well. You have 5 and you have 3. You have less than 5. So that's going to go this way. And greater than 3, it goes this way. So I guess you have a shaded region here. And if you put it, excuse me, if you put it in interval notation, it's going to be written like this. So all of those types of things. I think the interval notation, again, is the most important way to put it. Let's see, a number m is less than -3 or greater than or equal to 1. Okay, number m is less than -3 or m is greater than or equal to 1. So we put this on a number line. We have -3 here, open dot. We want that. 1 here, solid dot, going this way. We start putting an interval notation. We know that goes to -infinity, +infinity. So So the big thing I'm looking for here is I want or. You write it in interval notation. This would be written as negative infinity to negative 3, or parenthesis, or square bracket 1 to infinity. And again, I believe the interval notation is the most important part that you need to take care of. May I have your ID and your phone, please?
This boy's up.
Okay, problem number 6. A number S that is at least negative 2 or less than negative 6. So number S that is at least, help me out. You guys are, is it included or no? What do you think? Include, raise your hand if include. Raise your hand if you don't include it. I think you're right. So S is at least negative 2 or less than negative 6. Okay, again, we're looking to make sure you have 4 in there. If you have this on a number line, you get negative 6 here, you have negative 2 here. You'd have an open dot going this way, an open dot going this way. This is going to negative infinity, that's going to positive infinity, so I'll write it with that. Negative infinity, negative 6. What word am I looking for? 4. And then negative 2 to infinity. So again, that's in interval notation. Again, I feel that interval notation will be the most important way that you put that together. 7, you are purchasing a new refrigerator to fit in the space. The width of the refrigerator cannot be more than 42 inches. To meet your storage requirements, the width of the refrigerator must be at least 36 inches. So write a compound inequality. Okay, so the refrigerator can't be more, so it has to be less than or equal to 42. But it also has to be at least 36. So let's think on the number line how we'd represent that. We have 36 here, we have 42 here. I have a solid dot going this way, solid dot going this way. What kind of problem is this? It's an AND problem. So I can go ahead and list it like this in interval notation. Okay? All right. So, the next problems, a couple people have checked out the Big Ideas book, which is fine. I don't like how the Big Ideas book does it because they don't break it into 2 problems. They want you to just work it all as one problem. I disagree with that. Again, one of these days we'll get you over to check out the Big Ideas book. The reason I haven't done that is I don't really care for the book, so it doesn't. When do we get the book? One of these days. Sometime before May. I don't think so. If I thought it was a huge help to your stuff, I would.
Just like, what does it do? Like, it just shows you how to do stuff or something like that?
It's a textbook. We wrote our own textbook though. So what the district says here, here's a textbook you can utilize. I think it's fine. It's not a great thing by any means. I don't think it's going to turn a C into a B or a B into an A or an F into a D by any means. All right. Yep. 2 problems, yes? says solve the inequality, give the answer in interval notation. What kind of problem is this just by looking at it? It's an and problem, okay? So subtract 4, subtract 4. So I get negative 1 is less than x. So I could flip that over if I wanted to. It's up to you if you want how you want to put it. Subtract 4, subtract 4. Being it's an and problem means it would shade together. So I'm starting at negative 1, and I'm going to 6. And 6 has a square bracket, and that's how you would write it in interval notation. 9. I'm going to go kind of quick through these. Yeah, Bubba. Number 9, we got 15 is greater than negative 5t. I'll just write it as two problems now. So I have that. Divide by negative 5. So that means I have negative 3 here. Sign needs to flip over. Divide by negative 5. This is also an and problem. So think about this. If I flip this over, so I'm going to go between negative 3 and 2. So round a bracket at negative 3, square bracket at 2. Again, that's your interval notation. 10. I'm going to go ahead, it's an and problem. I'm going to break it into the two problems as I write it. And let's go ahead and solve it. So divide each side by negative 4. What's happening? It's going to be 3. Does the sign flip? Yes, it does. And then this one, subtract 8. So again, guys and girls, you can be filling this in if you need to. Double check your work. Let's see, I don't flip the problem yet. Divide each side by negative 4 because I divide by the negative 4. The sign has to flip over. So I want values that are, let's see, did I do everything right? Okay. Oh, I can change that over to this. So I want values that are bigger than 3, equal to 3, and less than and equal to 5. So square bracket 3, square bracket 5. Again, there's my interval notation. Okay? Number 11, it's an OR problem. How do I know that? It says OR. So h plus 7 is less than 5, or negative 9h is less than negative 45. So add 7 to both sides. So that's going to be, or subtract 7, so negative 2. Or divide each side by negative 9, so the sign has to flip over. So I get that. So remember an OR, sometimes it might be best to look on a number line what it looks like. This is going this way, and this is going this way. This goes to negative infinity, this goes to infinity. So if I write it in interval notation, it's coming from, we're reading from left to right. So it's coming from negative infinity going to negative 2, rounded bracket. The word OR is expected to be written, and it's going from 5 to infinity. Again, that's how you do it in interval notation. Because you're reading it from the left.
What did that happen like? Because how number the left one is first one is negative infinity and negative 2. What if you just were to flip those around in a test like on accident? Would it still count?
Minus 1 off. So just always read it from left to right. That's being read left to right as well. That's mimicking what's going on left to right on that. That's a great question. Yeah, it's not all points off, but it probably won't be 1 point off. That's probably a 5-point problem, so you get 4 out of the 5 points.
Yeah, if you know.
Yes. You will. All right, number 12 is an OR problem. How do we know? Well, the word OR is in there. All right, let's go ahead and start solving. So subtract 4. Negative 15 is greater than m, so I have m is less than negative 15. Divide each side by 2. So I'm going to get that to be negative 8. Again, if we're looking at an OR situation, let's take a look. I got negative 15 here. I got negative 8 here. So I want values doing this and values doing this. And again, I'm just using the number line so I can guide it. Out here's negative infinity, out here's positive infinity. So I go from negative infinity to negative 15, rounded, looking for the word OR, square bracket, negative 8 to infinity. Right, because I want values that are greater than negative 8. So it's going to go negative 7, negative 6, negative 5, 4, 3, 2, 1. 0, 1, 2, 3, 4, forever and ever and ever. Number 13, it's also an OR problem. How's that sticking out to me? Because it says the word OR. And I know that these, if it's an OR problem that's shading away, there really isn't any testing that I need to make work at this point. Or on the back side, I'm going to start getting to some that are going to get a little goofy that the test part will work. So there's an OR problem, should be shading away, so subtract 2, subtract 2. Divide by 3, or minus 8, minus 8. Negative W is less than or equal to negative 6. Multiply both sides by negative 1, so the sign has to flip over. Let's take a look at the graph. So I want values less than 1, so that's going to negative infinity. Values that are greater than or equal to 6, so that's going to positive infinity. And if we write this in interval notation, again, I'm writing it from left to right. So it goes from negative infinity to 1, rounded bracket at 1, so don't include it. The word OR I'm looking for, and then we're going to go from, that's a 6. We're going to go square bracket 6, because we include it, all the way to infinity.
So an OR problem is two different problems, but it's one.
Right. And you put the word OR, that's right there. We'll eventually have a symbol for OR because, you know, 2 whole letters versus a symbol. We'll stick with OR. Symbol looks like this. U. And the AND problem looks like an A. It's up there upside down. All right. Was there any questions up through number 13? I kind of went quickly, but those were ones that we didn't have to put the nuts and bolts with. Okay, meaning we didn't have to check a test point. But starting now, we might have to. Yeah.
So, if there is, comparing 8 and 9, there's x plus 3 is less than x plus 4, which is less than greater than 10. And then 9, if the variable is not alone, then you have to divide
By negative 5 on 9, and you just subtract 4 on number 8. Okay. Number 5, the sign's both flipped because you're dividing by a negative. All right, so number 14. And again, I think if you write the number line as a tool, it helps you to verify how things will work. What kind of problem does this appear to be? And. Okay, so there's 2 problems. And has to work for both. So I'm going to write it as 2 different problems. Again, the middle goes with both. And let's start solving it. Subtract 4, subtract 4. 20 is less than negative 5t. Divide each side by negative 5. So I get negative 4. Sign flips, yes?
Yes.
T. So then I can just rewrite that. I'm rewriting it so you flip the sign back over. So I have that part. So we'll see if that works for us. Subtract 4, subtract 4. Is that 12? Divide each side by negative 5. So t is greater than or equal to negative 12 fifths. Okay, so let's make a number line, see if this is going to work. So negative 12 over 5 is the same thing as negative 2 and 2 fifths. So negative 12 fifths is here. Negative 4 is even further to the left. Agree? All right, hang on. This is an open dot going this way. This is a solid dot going this way. This was presented as what type of problem originally?
And.
It was and. It was put together. So this means it had to be an and problem. And means it comes together. Okay? What do we see? We see an or situation. So if I were to pick a test point, so if I pick a test point that's to the left of -4, so we pick like -10, if I take -10 and plug it in, if I get, go back. If I plug -10 in here, or right here, I'm going to get 50 plus 4, that's 54. So 24 is less than 54. It works. But if I plug it in here, I get -50 plus 4 is -46. -46 is less. Wait. Did I goof that? What number was I plugging in above? -10. Right? So if I plug -10 in right here, this becomes 50 plus 4, that's 54. 24 is less than 54. True. If I plug -10 in here, I get 50 plus 4, which is 54. Is 54 less than 16? The answer is no. So it does not work out here at all. If I pick in the middle, it's definitely not going to work. If I pick over here, it's only going to be true on one of them as well. So it's not going to work on any of the regions with the test point. So what can we say?
No solution.
No solution. It has to work. So this problem has no solution. Okay, that's where the test point will come into play. So if you start graphing something and you know that an and should be coming together and all of a sudden it's doing outside, be leery about it. Or if it's an or problem and it's shading together, that probably still could work, but an and, they both parts have to work.
Would that be on the test?
You could see that, definitely. That's why I'm hitting it hard. Okay? So 15 might be the same thing. So we just had a goofy scenario that we had no solution on. What did I say about an or problem? How many parts of it have to be true? Or problem. I have this problem and this problem. Do they both have to be true? Not on or. One has to be true. The other one doesn't. And they both have to be true. The or, it's I have this or I have this. Okay?
So you have to figure out if they're correct or not for each one.
Right. Oh, I forgot to write before that. All right. So 3p, add 2 to both sides, divide by 2, or divide by 3. And then this one I'm dividing by 7. So let's look on a number line what this is going to look like. If I have -4 down here, yeah, I got a 0 here, I got 2 here. Okay? So on an or problem, I want values that are bigger than 4, and I want values that are bigger than or equal to 2. Are we okay so far? Okay, this is an or problem. How many of them have to be true? Only one of them. So let me ask you this. If I were to pick this 0, which is in between, if I plug 0 in here, I get 3 times 0, which is 0. Is -2 greater than or equal to 4? -2 greater than 4? No? That gave me one of the falses. If I plug 0 in here, 7 times 0 is 0. Is 0 greater than -28? So that gave me a true. So I have a false true. Over here I will tell you you get true true. Over here both will be false false. So your shaded region is going this way. Okay? So this is an or problem. But there's only one thing that we have to write about this or problem because we're shading both the right way and it's starting from here and going forever. So there's only one part of it. We don't have to say this or this. It's an or problem, only one way it's working. So for this problem to work, we're going to go from -4 to infinity, and we don't have to write anything else. What's the difference between this type of problem right now versus if this was an and problem? And is usually written just like that, but what does and usually have? 2 of. Let's go back to an and problem and just take a look at it. Okay? That's an and problem. Look at that right there. That's going from 3 to 5, yes? This one's doing what? What's it going from? -4 to infinity. Is infinity a different place than two whole numbers? Yeah. So that's why an OR works in this case with just one bracket. So be cautious on these, okay? 16, I have -n plus 5 is less than or equal to 9. And they give us an and, so it must be an and problem. If it's truly an and problem, what has to take place? They shade together, shade away. Shade together. Subtract 5 from both sides, so I get to 4. I'm going to multiply each side by -1, so the sign flips over. And this one, I get subtract 3 from both sides. Let's look on the number line. Excuse me. In order for an and problem to work, what has to be true? Both parts or only one part? Both. So looking at just our number line, we're going from -4 forever this way. We're going from 5 forever this way. So can we eliminate over here? This would be everything's false. Is that okay to say that? What about here? Just in between these two. Are both parts true here? What part's not? 5. What about over here? True, true? So if I pick, say, 10 and plugged it in, if I plug 10 in here, I'd get -10 plus 5 is -5, -5 less than 9, true. If I plug 10 in here, 10 plus 3 is 11, 11 greater than that. Yes, so my and problem is going to go from 5 to where? Infinity. It's not going to include this region because this was a true and a false. Over here was a false, false. Okay? All right, so we are going to go from 5 to infinity. So again, you're using a little bit of logic to make it work. If it's and, both parts have to have true test points. Or only has to have one of them being the true one. 17. A minus 6 is less than or equal to 3. Or 3a plus 2 is greater than 8. So add 6 to both sides on this one. That gives us 9. Subtract 2. That gives me 6. Divide by 3. That gives me 2. This is an OR problem, so it should be shading away. OR problems, how many parts of it have to be true? Only one. Okay? So if I have 2 down here with an open dot, and that's going this way, and I have 9 down here with a solid dot going this way, remember, it's an OR problem. So if this one is starting from here and it's going to go forever this way, where is this one going to? Infinity. If this one is starting at 9 and I'm going this way, where am I going? Negative infinity. No matter where I pick on this line right now, this appears that it's an and situation, but it's an or problem. So only one part has to be true. So over here, I'll have a true false. In the middle, I'll have a true true. Over here, I'll have a true false. Only one of them has to be true. So of the 3 regions, did I have at least one true in all 3 regions? So what can you tell me about the solution to these problems? It's an or. Only one part has to be true. Where's it true?
The 2.
Where's it true? All the way through. If it's all the way through true, what does that mean? All real solutions. I would.
All real solutions.
Okay, so the real number system exists. That's what everything you work in. How it becomes part of the complex number system or the imaginary number system is if you have a square root of a negative number. Okay, other than that. So some students might also put infinite solutions. At this point, I would probably accept both answers without a problem. Okay, if it's a multiple choice test, I would have this as the answer. I would not have infinite solutions. Okay? So that's a trick on that one. Why is the trick? Because or. You only need one part of it to be true. All right, so for the rest, it says use a graph to simplify the inequalities and write the simplest inequality in interval notation. So these are quicker. 18. So on a number line, I want bigger, and I want bigger. This is an and problem. Do I need to have true, true? So over here, what would this give me as a solution? True, 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 false, or false, false? False, false. What does this give me? True, true, false, false, or true, false? True, false. What gives me over here? True, true. Okay, it's an and problem. I need to have true, true. Still with me? So where does this work? It goes from 6 square bracket to what? Infinity. Okay? Over here, we'd have false, false. In here, we'd have true, false. Over here, we'd have true, true. We've broken the number line into 3 portions. We have a false, false portion. We have a true, false portion. We have a true, true, false, or true, true portion. Identify with an and as true, true. If it's an or, you're only looking for at least one of them being true. So you're looking for a true, false, or a false, true, or a true, true. 19. If I have this, what am I looking for on my number line? It's an or. So what does it mean? It's an or. So what happens? I have this in 3 sections. Here's a section. It happens to go to infinity. Here's a section, which is bound. Here's a section that goes to infinity. Where does this have? Where's false, false? Is this false, false? What's in here? A true and a false, and what's over here? True, true. I need at least one true for the solution to work because it's an or. So where do I start on this one? Where do I start? At 2. Where do I go to? Infinity. Look at the difference between these. 18 had and. 18 started here. 19 had an or, so you included this region. So over here we had false, false. Here we had a true, false. Here we had true, true. With the test point. Am I making it clear? It's talking about a test point. Okay? So don't be the student going, oh, I don't need to try test point. You're going to get it incorrect. I don't understand a test point. Pick a number to the left. How do I know what's to the left? It's less than it. How do I know it's in between? It's something in between those two. Well, which one? Any of them. Pick a number to the right. Well, how do I know it's to the right? Something to the right of where your last unit is. Okay? I mean, if you pick the test point over here, you could pick negative 255,317. And it's going to give you false, false on both. In between the two, I mean, you have 3, 4, 5 you could choose. Okay? To indicate a true, false. What's to the right of this? I don't know. Positive 10. Positive 10 trillion. Positive, huge numbers if you wanted to go that way. But you're not going that way. You're just trying to figure out, make it simple. Okay, number 20 is an or problem. Okay, how much of an or problem, number 20 is an and problem. What am I looking for an and problem? False, false, true, true, or true, false? True, true. So I want values less than 3. I want values bigger than 5. If I pick a number to the left of 3, a number left of 3, oh, I don't know what it would be. 0 maybe? Is 0 greater than 5? Nope. Is 0 less than 3? Yep. So I got a true and a false. If I pick something, oh, that's I guess a 5. What's the number between 3 and 5? Oh, I don't know. I can't think that hard. No, it's 4. Okay? And I'm being sarcastic because it's funny because there's times some of you get to my office. Okay, pick a number between 3 and 5. 19. You're close.
3 to 5.
I mean, sometimes the answers that you all come up with, it's just like, how'd you find your way back here?
Yeah.
I mean, I'm not trying to be mean. I've been teaching for a long time, and it's funny because it's like either my vocabulary makes a lot of sense in my head, and then when it comes out of my mouth, it makes no sense, which is very possible. But, so this is an and problem. If it's and, I have to have true, true. So over here, I have true, false. In between these, I have false, false. How do you know? Oh, well, let's pick 4. We said 4 is between 3 and 5. How do I know that? Because on a number line, it falls in between 3 and 5. Kindergarten, let's go from there. So plug 4 in. 4 is greater than 5. Nope. 4 is less than 3. Nope. Middle section's false, false. Okay? Pick a number that's bigger than 5. I don't know. I once knew a number that was bigger than 5. You did? Maybe your address? I don't know. I'm being sarcastic, but again, it becomes funny when I ask you, sir, for something that's bigger than 5, you're like, 3. No, it's bigger than 5. -7. No, it's bigger than 5. It means it's to the right. Okay, so I'm going to the right. So pick 10. 10 is greater than 5. Yeah. 10 is less than 3. No. What is my solution? Say it. Good. No, and we'll go with no real solution. Make it 5. Okay, some of you like to write that. Totally fine. Yeah.
So if it's this type of problem, you're saying what goes in between, and then you're trying to figure out if it's bigger than the other number, less.
I'm trying to see if whatever number I plug in,
Yep.
does it make that true or does it make that true?
Okay.
If it's an and, I have to find what region. There's 3 different regions on that graph. None of those regions will allow us to have a true and a true statement. Okay? 21 is what kind of problem? Or. So what does an or problem need to have?
At least one solution.
At least one solution, correct. So a true, true works, and a true, false works. A false, false doesn't. So let's take a look at what this problem does. Okay, I want values that are smaller than 3, so that's going this way. Values that are bigger than 5, that's going this way. Okay? Does this appear to be every or problem we've ever worked? What do you think? Yeah. So the region that won't work, this will not be a working region in between those. Okay? This went to negative infinity, this went to positive infinity. So from negative infinity to 3, rounded bracket, or from 5 to infinity. That one totally works. Remember, if it's just going to be a traditional or problem, it looks like that. It should work no problem with you without even worrying about test points. Okay, this says, hey, everything to the left of this will give me at least one true statement. Everything to the right of this will give me at least one true statement. If I pick something in the middle, it'll be both false. How do I know? Well, let's pick the number 4. How do you know that 4 is in between 3 and 5? Because I learned to read a ruler. So 4 is greater than 5? Nope. 4 is less than 3? Nope. So it's false, false. So that middle region doesn't work. 22. X is greater than 6, and X is less than or equal to 10. What does an and region have? What am I looking for an and? Two solutions, two truths. Okay? So I want to go from 6, open dot this way, and 10, close dot this way. Does this look like a normal and statement? It does. They're coming together. So if that's a 6. So if I put it in interval notation, it goes between 6 and 10. That's it. That's a traditional. I didn't have to go and test it. Why? Because it looked like a normal and problem. Why did I not have to check the or on the last problem? Because it looked like a traditional or problem. Why did I have to check this one? Because it was an and problem and it graphed like an or problem. Why did I have to check this one? Because it was an or statement that both went the same way.
Number 24 is appear the same.
Are they?
Yeah, wait, almost.
23?
Oh.
23.
They're or. Yeah.
Okay, it's an or statement. How many parts of it have to be true?
At least one.
At least one. Let me ask you this. What kind of graph is this? What does it look like? It looks like an and. So I'm going from 6 forever that way. I'm going from 10 forever that way. It's an or problem. So I'm looking for how many true parts to it. 1. So down here would give me true, false. In the middle would give me true, true. Over here would give me true, false. What can you tell me about the solutions? All real solutions. Or infinite solutions.
Because they'll go through.
It'll include every point. So remember, an OR problem is 2 problems. I've built these problems. No matter what number I plug in, at least one of those will be true. It's possible both are true, but at least one of them will be true. So I'll do 24 and 25. We're going to do both of these on the same thing. So 24, x is greater than 2, and x is greater than 7. The other one, excuse me, x is greater than 2, or x is greater than 7. So let's look on our number line. And where do we have to have true? And where does it have to be true? Do we have to have true, true, or one of each? I will tell you that this region right here is the only true, true region. Over here is false, false. Over here is true, false. Okay? As far as the or goes, so the and, we're looking for this region right here. So problem number 24, you have from 2 to 7 as your answer. For the or, we're looking for only one region to be true. They both could be true. So for number 27, this goes from 2 to infinity. Okay? So, for this evening, I want you to make sure that page 41 and 42 are complete. Notice I picked a whole bunch of test points. And then I'd like you to continue with 43 and 44. I will mark those both off together tomorrow. Okay? We good?
Yeah.
All right. Was I sarcastic enough? Probably. Okay, did I offend you? I'm sure I did. If I offended you, I apologize kind of. But I love you guys too much to have to apologize profusely.